which one we left off on. I think we did the piecewise, first piecewise function, right? We did that. We did that. We did that. Okay. So we're going to start here, number 5 on your paper. For the piecewise functions on Monday, remember you will only have one or the other type of question. All right, so this one is where we're going to graph it. The one that we did together before was where you had to find the equation. So only one of these will be on the test. That'll save you a little bit of time as you're going. All right, so we want to graph the piecewise function and then state any values of x where we are discontinuous, and we'll review that when we get to it. All right, so let's make our table. Okay. And I have 3 pieces of my piecewise function, and each piece should have 2, I would say maybe even 3 points, so you can get a nice, decent picture of what that piece is going to look like. All right, so my first piece is y equals x squared plus 5, y equals 2x minus 1, and y equals negative 6. All right, so for x squared plus 5, what numbers am I allowed to plug in for x? Negative 3, everything less than negative 3. We also want to include negative 3. So I'm going to use negative 3, negative 4, negative 5. Because my values get really close to negative 3, they don't touch it. I don't want to stop at negative 4 because then we miss a whole unit on our graph. So I'm going to put negative 3 there, but I'm going to a little mental note to myself there that it's going to be an open circle when I graph it. So that'll be the end point of that piecewise function. All right. And let's just do these one at a time. So let's go ahead and plug these numbers in. We're just going to square them and add 5. Remember, you're going to have a basic calculator again for this on Monday. So negative 3 squared, 9, plus 5, 14. Negative 4 squared, 16, plus 5, 21. And negative 5 squared plus 5, that's 25, plus 5, 30. So that one's going to go a little off. That's okay. All right, let's look at the next piece. Y equals 2x minus 1. So that's the one in the middle there. I can use any value between negative 3 and 4. Negative 3 is inclusive. You want to make sure at minimum negative 3 and 4 are included in your table. Those end points again, where it breaks from one piece to the next. Negative 3 here will be a closed circle. 4 here will be an open circle. And then you can pick any other number to plug in the middle there. I'm just going to pick 0. That seems easy. Okay. So 2 times negative 3, that gives me negative 6, minus 1, negative 7. Plug in 0, I get negative 1. Plug in 4, 2 times 4 is 8 minus 1, gives me 7. That's the middle piece. And then we've got one more piece to go. Y equals negative 6 is defined for x values greater than or equal to 4. So I definitely want to use 4. 4 is going to be a closed dot there. And then any number bigger than 5 and 6. Now this one's interesting because is there an x in the equation? No, so there's nothing to plug in. So no matter what number I choose for x, the answer is always going to be what? Negative 6, because this is a horizontal line. Every point on this line has a y coordinate of negative 6. All right, so I'm going to start by graphing that one. 4, negative 6 is a solid point. 5, negative 6, 6, negative 6, and that was defined for values greater than 4. So I'm going to start at my point 4, and am I going to go left or right to extend this line? If it's greater than, which way do we go? To the right. So there's your first piece, and you can see that horizontal line at y equals negative 6. The next one is also going to be a line, y equals 2x minus 1. Has a y-intercept of negative 1 and a slope of 2, so we should expect to see a line going up from left to right, if you want to just kind of mentally check that as you go. So negative 3, negative 7 is a solid dot. 0, negative 1 is solid, and then 4, 7 is an open circle. And that piece is contained between negative 3 and 4. So I'm just going to connect my dots, and they do not go any further than those values. That's why it's helpful to use those endpoints, because I know where it starts and when it stops. And I know it's going to be a line because it's in that y equals mx plus b form. Now the last one's going to be off my graph quite a bit here. -3, 14 is going to be like up here somewhere. And then it's going to be a parabola, so I'm just going to say it's going to like curve up to the right there. You could always count by 2s if you wanted to also, extend your graph, whatever. Okay. And I know it goes forever to the left there because its x value is less than -3. That tells me from -3 to extend to the left forever. Just make sure you show that it's a curve there because it's a parabola. All right, the only other part of this question is name where it is discontinuous. These functions can only be discontinuous at x values where it breaks. What are my 2 breaking points here? What 2 x values? -3 and 4 are the only possible answers to this question, okay? Discontinuous means at -3 or at 4 or at both, do I have to pick up my pencil to be able to trace it? And the answer is yes, right? Because none of these pieces actually are on top of each other. If one piece started where the next one ended, we would say it's continuous. But at -3, it jumps to another piece, it skips values, and at 4, it skips values. So I am discontinuous at -3 and at 4. Those are 2 places where the graph has breaks, where I have to pick up my pencil to be able to trace it from left to right. And again, if the pieces touch, it's continuous at that point. What questions do you have on this one? There's a lot of little things on this one you got to worry about. Nothing? Okay. All right, the next one is all of our combining, composing stuff. First one, c minus d of x. Remember, you can write this as c of x minus d of x if you want. If it's a variable there instead of a number, you are just combining those functions together in that manner. So here we're taking function d and subtracting function f. Our answer should be a new function when we do this. So c is 4x squared minus x plus 3. Be careful with subtracting. Remember, when we subtract something, we want to put that in parentheses, just like we do with our difference quotient, so we distribute the negative through correctly. 5x minus 1 goes in my parentheses. Distribute. So I'll have negative 5x plus 1. And then combine your like terms. So final answer should be 4x squared. I have a negative x and a negative 5x, so negative 6x plus 4. And remember, that's your answer. This new function you've created, you are not solving it. Down to letter B, right below it, multiplying function c times function d. 4x squared minus x plus 3 times 5x minus 1. Now remember, when we did these in class, we talked about this is just a really big distribution problem. You're taking everything in the first parentheses and multiplying it by everything in the second parentheses. Because I have 3 terms and 2 terms, I know I need 6 terms that have accounted for all my multiplication. And you can even make a little grid if you need to, a 3x2 grid, and multiply it that way if you've done that in the past. All right, so I'm going to distribute 4x squared to the second parentheses. That gives me 20x to the third minus 4x squared. I'm going to distribute negative x into the second parentheses. That's negative 5x squared plus x. And then 3 into the second parentheses, 15x minus 3. Combine my like terms, and I've got my answer. 20x to the third minus 9x squared plus 16x minus 3. Questions there? All right, letter C. We are plugging a function into another function. We got that double parentheses. What's being plugged into what here? D is being plugged into C. So we're going to take function D and we're going to put it into function c anywhere where there's a variable, and we're going to replace it with a parentheses there. There are two variables, so there are two places where we're going to be plugging that 5x minus 1 in. Let me move that up a little bit in a second. All right, so that's going to look like 4, take the x out, 5x minus 1 in its place, squared, minus 5x minus 1 plus 3. Okay, what do I do first to simplify this? You, go ahead. Say it again. FOIL. Perfect. All right, so bring down my 4. FOIL what's in the parentheses. You can hopefully do this mental math real quick. 5x times itself, 25x squared. Outside and inside are both negative 5x, so that's negative 20x, or 10x. And then last term, 1 and 1, give me 1. Bring everything else down. Then you distribute, then you combine like terms. If I distribute, I get 100x squared minus 40x plus 4, don't forget to distribute your negative in, minus 5x plus 1 plus 3. And then combine your like terms. 100x squared minus 45x, and then 4, 1, and 3 give me a positive 8. Okay, final answer. Good so far? Any questions on any of those? Okay. All right, now letter D is just the opposite. We are plugging what into what here? Helps if you write it like this with the double parentheses sometimes. C into D. If you don't like that open circle, an open circle, that's a big difference between multiplication and composition. So closed circle, like letter B, multiplying. Open circle, like letter D, you're composing, plugging one into another. Double parentheses tell me C into D, so it's just the opposite. I'm going to take that whole function C, put it into function D where I see the variable, and there's only one place where I've got to plug it in. So 5 parentheses. 4x squared minus x plus 3 minus 1. No foiling to be found here. Distribute, combine like terms. 20x squared minus 5x plus 15 minus 1. Final answer, 20x squared minus 5x plus 14. Okay. All right. Letter E and F then, there's not a variable in the parentheses anymore, there's a number. So these ones we should expect to get a number answer out. The first one, it is two functions subtracted. So we're going to plug -5 into C, we're going to plug 4 into D, and then we're going to subtract those two answers, whatever we get. And again, you can do this mental math maybe. You can use your calculator if you need to when you're plugging it in. Just be careful with negatives and parentheses and things. If I plug -5 into C, I'm just going to do that quick mental math here. So -5 squared gives me 25 times 4 is 100. Minus -5 would be 105 plus 3 should have 108. And again, you can use your calculator for that if you need to. Plug 4 into D. That's 5 times 4 minus 1 gives me 19. And then subtract my answers gives me 89. Good there? Okay. The last one at the bottom is D of C of 1. This is composition. You work from the inside out. So we're going to start with C of 1. If I plug 1 into function C, I would have 4 times 1, so 4. Minus 1 would give me 3. Plus 3 would give me 6. And now I plug 6 into D. So that would be 5 times 6 minus 1. Final answer there should be 29. Questions on any of the composing, combining, all this 2-8 stuff? Okay. Moving along. Okay, the next two problems are practice for inverses. I'm going to change g of x to a plus. The minus makes it a little difficult, and you'll see why in a minute. It doesn't make it harder to find the inverse, but it makes it harder to find the domain and range. So I'm just going to leave it as a plus there instead of a minus like it originally was written. All right, so finding the inverse, we're going to switch the x and the y first. Remember, g of x, or any function notation, can be written as a y. Switch them. X equals 4 plus the square root of y minus 5. How do I solve for y? Subtract the 4. Now that my square root is alone, what do I do next? Square both sides. Don't simplify the squared. It's not worth it. Okay, just leave it like this. X minus 4 squared equals y minus 5. There's no need to FOIL. We definitely don't distribute the square through. That would be terrible. Last step to get the y alone is to do what? Add 5. So x minus 4 quantity squared plus 5. At the very end, instead of y, I need to see your function notation back in there, and I want to see the inverse symbol. Okay, so my original function was g of x. Your inverse symbol should always go between the name of the function before the parentheses. If you put it anywhere else, it means something different. It means take it to the -1 power. We don't want to do that. Okay, we'll come back to domain and range in a minute. Let's go ahead and do the other one. H of x, I'm going to replace with the y. Switch my x and y. X equals 4y cubed plus 2. How do I solve for y? Subtract 2. Trying to get that cubed alone there. So the next thing I would do is divide by 4. And again, there's really no need to simplify as you're doing this. I'm just trying to get that y alone, so I'm just going to say the whole side over 4. And then how do I cancel out a third power? Cube root. X minus 2 over 4. And again, instead of y, h inverse. There is no need to simplify any more than that. Okay, so questions on finding an inverse. How we're doing this. Switching our x and y, solving for y, putting back in our function notation. All right, let's talk about domain and range. I'm going to do the one on the right first. Domain of the inverse. We're finding domain and range of the inverse. Does my inverse have any restrictions? Is there a square root or an even root? No. Is there a variable in the denominator? No. So the domain of my inverse is all real numbers. Only if you have an even root, which this is an odd root, most of the time it's a square root that we see, or a variable in the denominator. So domain is all real numbers. To find the range, remember we look at the original function. So does that original function, 4x cubed plus 2, have any domain restrictions? Denominators, square roots? Nope. So both the domain and range on this one are all real numbers. Okay. Now, the second one is tricky. And here's why. I'm going to start with range. Okay? Range is the domain of the original function. I definitely have domain restrictions because we have a square root. So to solve for that range, I'm going to take what's under my square root. You should have done this yesterday on your test. Said that's got to be greater than or equal to 0. So x minus 5 greater than or equal to 0. So x has to be greater than or equal to what? 5 in the original function. So the range of my inverse is 5 to infinity. Now here's why it's tricky. Think about what a square root function looks like. It looks like half a parabola on its side, right? If I find the inverse of that, am I going to get a full parabola? I'm not. I'm only going to get half of a parabola. And we don't see where the restriction is in the function. So the easiest way for me to tell you to do this is to make a quick kind of mental sketch of what this is going to look like. What two transformations are in this function? If there's a minus 5 in there, what does it do? Right 5. And what does the plus 4 do? It's usually at the end, but it moves it up 4. Okay, so think about my square root function. My square root function looks like this, right? And all I have to do is move it right 5 and up 4. Right 5, up 4. That's the new function. If I want domain of the inverse, what do I look for on the original function? The range. And from that sketch, can you tell me what the range is, the y values? What's the lowest y value? 4. And how high does it go? To infinity. That's it. Those square root ones are tricky. Make a sketch if you're not sure. You can even do that for the other one too if you're not sure. You can sketch out what a cubic function looks like and stretch it and shrink it and kind of think about, are there any restrictions there? But that one's a little crazy. Okay. Questions on that one? All right, last problem is the one that has all of my transformations on a function. Now, what I'm going to start by doing here is just label these 3 points, because the 3 points are what I'm going to use to actually get the transformed graph. So I've got 0, 3, I've got 3, 6, and I've got 6, 1. Okay. The next thing I would do, if I were doing this problem, I think the easiest method would be to name my A, B, C, and D from the equation I'm given. What's the A? Number multiplied out front of the function. There's a negative there, right? So what number is that? -1. B is the number multiplied inside. It's a 0.5. I'm going to write it as a half. C is the number added or subtracted on the inside. Is there a number added or subtracted in there? Nope, 0. And then D, number added or subtracted on the outside. It is 2. Here's the formula that we used. It was reciprocal of B times X minus C. That's how all my X coordinates are going to change. That'll give me my final X coordinates. A times Y plus D. That's how my Y coordinates are going to change. It's going to give me my final Y coordinates. What's the reciprocal of B in this problem? 2. X minus C. You can say minus 0 if you want, or you can just ignore it because that's not going to change anything, right? And then A times Y plus D. So -1Y plus 2. So this is what we're going to do to all our points. We're going to take the X coordinates and multiply them by 2. We're going to take our Y coordinates and we're going to make them negative and add 2. All right, so let's start with the X's. Multiply them by 2. 0 times 2, 0. 3 times 2, 6. 6 times 2, 12. Those are your new X coordinates. Y coordinates, make them negative and add 2. So I'll have a -3 plus 2, -1. -6 plus 2, -4. And -1 plus 2 gives me 1. Yep.
That last one should be 6, 0.
Oh, yes, it is. Thank you. You guys are just like letting me roll with that. 0, 0, so that changes that then. Just be a positive 2. I don't know why I did that. That's weird. Everything else look okay? All right. All right, the other way to get these points are you can physically do the transformations on the graph. You can reflect it over the x-axis. You can do a horizontal stretch by 2, and you can shift it up 2 units. But that's going to involve drawing several graphs, and that can get a little bit messy. So I would definitely put a little star by this formula. Know where A, B, C, and D are located in your transformation rules. And if you can write that, you can change the points fairly easily. Okay. All I have to do is graph them. 0, -1, 6, -4, and 12, 2 is going to be off my graph just a little bit over there. Looks something like that. You should be able to see those transformations. You can see it's been reflected over the x-axis. You can see it's gotten wider, that horizontal stretch of 2. The only one that's a little bit difficult to see is the shift up 2 there. Those are a little harder. Okay. That's it for your test review. All right, so besides these problems we talked about today, you also want to make sure you look at rate of change and difference quotient that we did the other day. That's what's going to be on your test on Monday, basic calculator, right? What time do we get out of here? 10 o'clock. Do you guys want to go out in the hallway, or you just want to look at the Polaris stuff? Just look at Polaris. It's the same questions. Okay, so maybe wherever you left off on Tuesday, or when did we do that? Wednesday in the hallway, if you were like in the A's or the B's or the C's, you can maybe find that same form of the blank questions online. Try a few problems this weekend. Try them now if you want, and then test on Monday, all right? I'll do the cell phone lotto for you, and the last 15 minutes are yours to look over anything, ask me questions, whatever you guys need.